In this graph, there are no intervals of constant. There's points of constant, but we're not there yet. And it's not asking for that, it's just asking for an interval. So there is none. So you can write none. The fancy mathematical way to write that is this 0 with a line through it. It's the empty set. You can even put little curly brackets around it and say it's an empty set. There's nothing in it. It doesn't exist. There are none. What is the function's domain? I think you guys can handle that one on your own. The function's domain is between -3 and 5. So we could write it as domain equals curly bracket x values such that, and then we can say between -3 less than or equal to x less than or equal to 5. Close your curly brackets. That is one way to write domain. That's what we talked about the last time of the only way to write domain. I lied. There's two ways to write domain. This is one way to write domain. The other way to write domain is in interval notation. How we wrote these intervals up here is interval notation. So we could also write our domain as an interval. It represents a range of values. It's an interval of values that go in for our x. So it goes from -3 to 5. So a different way to write it, -3 to 5. Now with domain, because there's a closed dot at the ends, we are including those values in our domain. So instead of a soft bracket, now we learn about something called a hard bracket. A hard bracket does include the values. Think of it as your closed dot. If you maybe want to put like an open dot next to this guy and a closed dot next to this guy, that might be a helpful hint to you. So if we're including the values -3 and 5 in our domain, as you can see with the or equals to here, we would put little hard brackets. There you go. Go ahead and solve for the range on your own. I want you to put it in interval notation, please. The range is just a slight shift of viewpoint. We're looking at this idea of closing a window. How can we close a window on this graph? And we're stopped down here at the negative y value of -2. So we go from -2 all the way up to, and then this is a y value of 7. Because we're including those values, we put little hard brackets there on the end. If you wanted to write it in set notation, so this guy is set notation, this is interval notation, you would write it as r equals curly bracket y such that -2 is less than or equal to y, which is less than or equal to 7. It's kind of a mouthful way to write it, and that's a mouthful way to say it, but it does kind of look really smart, so that's always fun. All right, next problem. Identify any relative maxima or minima. Your maxima or minima is when the behaviors change on either side. So where it might be decreasing on one side and then it starts to increase, or maybe it's increasing on one side and then it starts to decrease. It's not the ultimate maximum. It's not the ultimate minimum. It's just where the behavior changes every time the behavior changes. There are 3 places where the behavior changes, and that's here, here, and here. Your endpoints are never relative maxima or minima because it's not a behavior changing, it's just a stop. So it's different. So because relative maxima and minima need to be where behavior changes, because there's nothing happening on the other side of your endpoint, there is no change of behavior. There just is no more any behavior. Okay, so you have 3 of them and you just list them. We can list them as max and min. Our maxima is going to be at this point right here, which is 1, 7. And this is a point, not an interval. So you can see where that might get confusing. So you need to make sure to use the context of the problem to understand whether it's a point or an interval. I guarantee you, multiple of you are going to make that mistake. So just be aware of it. Okay, your minimum, you have 2, which is why we call it the plural minima. You have 2 minima. One is at -1, 5. and the other is at 4, -2. No union for this guy because we're not talking about like interval or set notation. It's a point. And so there's no like union type of situation with points. Okay, let's move on. Where is the function positive? The function being positive occurs at certain intervals. So we're going to give this answer as an interval. In this and positive here, they mean the y values. When they say, where is the function positive? The function is y. F of x, the function of x, is y, okay? So where it says, where is the function positive? They're saying, where are the y values positive? And there's a range of values. It's positive all the way over here because we're above the x-axis. So all of our y values are positive up till we hit here. And then it becomes negative. Since it never goes above 0 at 5, there's only one interval where the function is positive. And it starts here where it's positive, and then it ends here. Again, we're still always looking at that x-axis. Intervals are always given as an x value. So we start at -3. So I'm just going to write -3, comma, and then I end at +3. And now I have to think of, do I include the value or do I not include the value? At -3, we are definitely positive at -3. So we can include -3 in this interval. However, at +3, we are at 0. And 0 is neither positive nor negative. It's the doorway to positive or negative. So you cannot include 3 in this interval. We're saying everything leading up to 3, 2.5, 2.6, 2.7, 2.8, 2.9, 2.99, 2.9999999 are all positive, but the moment you hit 3, you're at 0, which is no longer positive. So we don't include 3, but we're saying everything up to 3 is positive, and then basta, done. Okay. So that's an interval. A little bit easier to tell because we've got a hard bracket. But the context of the situation is saying, where is the function positive? So it occurs over an interval of time, interval of x values, which we see. Where is the function negative? I want you to go ahead and try this on your own. The function is negative starting at 3 and going till 5. This is where our function is negative because our y values are negative. The function being negative is our y values being negative. So it's between 3 and 5, and then we go back and say, okay, which ones do we include, which ones do we not include? We happen to not include either of them in this case because they both start and end at 0, which is neither positive nor negative, so south brackets, but an interval, not a point. Have I driven home that yet? Hopefully. Okay, these last ones are pretty easy. It's what you did on your previous notes. So I'm going to let you do both of them on your own. The first one, f of 3. I am trying to find the y value when x equals 3. So that means I go find x value of 3 and my y value is 0. F of 3 equals 0. That is the point, 3, 0. Right? We can take that information all the time. Where is f of x equal to 6? This I put in here on purpose because there are 3 answers. Okay, this is the y value of 6. We have 3 different places where your function crosses that y value of 6. And yes, it's still a function because it still passes the vertical line test. So here is one x value. That's an x value of -2. Here's an x value of 0. And here's an x value of 2. So you should have given me -2, 0, and 2. X equals yada yada.